Alright, in this video we're going to kind of explain how to, one, fill in the Gliding Along Lab table, and then two, how to make graphs using Google Sheets. So you should all have a copy of this document with the Gliding Along Lab table. A lot of the information is already filled in for you. The first thing it says to do is make a copy of this document. Basically what I'm going to have you do is, because you don't have editing privileges of this, so you need to make a copy of it so you can do that. So you can do that by going to File, Make Copy. And you can just label it as Gliding Along Lab, and then put your first and last name. I'm going to put Michael Jordan. Alright. So then it'll pop up a copy, and then now you should be able to edit this copy. All right. So now I can actually type in some numbers here, and basically what you're going to do is type in numbers into these boxes here. So I typed in 55. Right. So what you're going to do is you're going to do the calculations. You can do it on a separate sheet of paper. I don't need to see the calculations. I'm just going to look at your data table, see if it's correct or not. And if you go through, you're going to calculate the average total time for all 8 meter markers. So for the first meter, you're going to average these 3 times and get those averages. Now I'm just going to make up a number here. It looks like it's like about 0.85. Now, if you do the uncertainty for it, if you're an IB1 student, I'm going to have you guys do the uncertainty for it, the plus or minus thing. And to do that, what you're going to do is you're going to go to Insert Equation. And when you do, when you get Insert Equation, you're going to get all these little tabs right here. I have to look around a little bit. I think it's this one right here. The second one down, you see this plus or minus. So I hit this plus or minus, it gives me the plus or minus. And then I use the arrow to the right to go over, and I can put the plus or minus there. I want to figure out what my uncertainty is by taking the average, which is this, and subtracting each one, and then finding out which one's the farthest away from the average, and then putting that value in there. All right? I'm totally making these numbers up. Don't put this number. Then you're going to go through and fill in the interval time for each of these. So I'm just to put the interval time. Same thing. You're going to go to new equation, plus or minus, put in whatever that interval time is, plus or minus uncertainty thing. And the interval velocity, maybe this is like 1.5, plus or minus 15. And then make sure you put the percentages on those ones. Now, if you're just physics B, don't worry about the plus or minus stuff, right? You can fill in this whole table. Make sure that you actually calculate it out. Don't just put random numbers like I did, and you're going to calculate it out. Okay. Once you have your table filled out, then you're going to actually plot some data in a graph. So to do that, we're going to go to a new tab here. We're going to go to Google Sheets, right? You go to sign in here, and then just make a new blank document. And then what you're going to do is you're going to put your x-axis. In this case, our x-axis is going to be time. So I'm going to write down time with parentheses s, because that's the unit for time is seconds. Next to it, I'm going to put down my y-axis. In this case, it's displacement. And my units are meters, or parentheses meters. So now what you're going to do is you're going to end up making 2 graphs. One that is displacement in time, and the other one is velocity in time. So what I would do is I would input my time value, so like my average total times. So I'll go to this, and I'm going to put my average total time, so 0.85. Don't worry about the uncertainties. Just put in like 0.85. Maybe the next one was like 1.7, whatever. Maybe the next one was 2.9, right? So what you're going to do, you're going to just fill in this data for the average total time. I just made all this data up. So whatever you got for the average total time values, to 0.85, whatever you got, put those values down for this. And the displacement is actually really easy. It's going to be 1 meter and 2, 3, 4, 5, up to 8. to 2 meters, 3 meters. You don't have to put like the 4.00 because it automatically changes it to 4, 5, 6, 7, 8. Don't worry about the uncertainties. We're going to worry about that later. And now that you have your data, make sure that the time is on the left and your displacement's on the right. Make sure that you have those in the right order. You're going to highlight it by clicking on this and just kind of clicking and dragging, and you're going to highlight it so there's a box around it. Then you're going to go to Insert, Chart. Now, it might take a second or two. It's going to make this chart here. And look at this. It makes a nice graph for you. It gives you a title, displacement, meters versus time, seconds. It labels your axes for you. Now we're going to just kind of play around with this chart. So we're going to go to Chart Type on the right-hand side here and go click on the Chart Type and make it dots instead of a line chart. Then we're going to go to Customize. We're going to focus on Series. So if you click on Series, we're going to scroll down a little bit until we get to Trend Line. Okay, we're going to click on Trend Line, and we're going to make it linear for this one, and then we'll show the R-squared value. And also, we're going to click on Label, Use Equation. So now, if you double click on this, it tells you an equation. It says 1.12 times x plus negative 0.0621, r squared is 0.997. We can actually change the font of that. I'm going to make it a little bit larger so you can read it. Make it bold. And maybe double click on it and just kind of drag it. Oh. We can kind of drag it around, maybe move it down. Okay, a couple of things we could do, just some formatting things. If I go back to series, I want to add my error bars. I'm going to go down and add error bars. And now I need to tell it what error bars to add. You can add a percentage or a constant value. I'm going to leave it as a percentage because what I'm going to do is I'm going to add my interval velocity, and I'm going to go down my list and find the largest percentage. I didn't do the calculations because I just made up numbers, but let's say this is 15%, this was a 20%, this one was 15%, this was 80%. I'm going to look at the largest number, my largest percentage, and I'm going to put that as my percentage. So I said 80%, so change it to 80, and do that. All right. So then finally, I'm going to click on this graph, and I'm going to go up to Edit and go to Copy. Then I'm going to go back to my Gliding Along lab, scroll all the way down, make sure you're outside the table, maybe go to the next page, and go Paste. Or you can go Control V. There you go. There's my graph. Now, I'm going to make one more graph. I'm going to go to my velocity. So I'm going to leave the time values here, but then I'm going to change this to velocity and make it meters per second. I'm going to change these velocity values to whatever I calculated here. So the 1.5, whatever this is. Like I said, these are all made up numbers. Yeah, I'm going to say like 1.5, maybe this was like 1.7, and like you said, leave off the uncertainties for now and just come back to them later. So I'm making these numbers up as I go. Really have no idea what they're going to be. So maybe let's something like that. Then it automatically changes this. But if you notice, it didn't change the title. So I don't like that. You can double click on the title and change it yourself. Velocity, make sure you change it to meters per second, and double click on this and make it velocity and meters per second. That's one way to do it. A second way to do it, which if you wanted to, I could just highlight these again and just go to Insert, Chart, and it automatically does it. But then I have to change. I have to make sure I go back to series and put the trend line back in, the error bars, and all that stuff. So now the percent error bars you're going to do for this are that's going to be the percentage uncertainties. You can look for the largest percentage uncertainties and put that down. So that'd be like 80%, like I said. I actually screwed up in the displacement versus time graph. The uncertainty should be a constant value. Should be a constant value. The constant value for the displacement is 0.03. So technically, I should put in 0.03 for the constant value. And if you notice, it might not even pop up because they are very small. So it might not. Now this one definitely should pop up, as the velocity values will have a much bigger uncertainty. You're going to have your best fit line here, and it should automatically adjust it for you. Then finally, once you're done with this graph, you're going to click on it, go up to File, Edit, Copy, or Control C. You can do Control C as well, and then go down underneath your other graph and go Control V or just paste. All right. So basically, you should have two graphs at the end of it. You should have your data table all filled out with numbers, the correct numbers, not just made up numbers like I have. You should have the correct numbers in all these boxes. You should have your two graphs. If you're IB1, you should have the uncertainty bars on there. If you're Physics B, don't worry about that. You should have the displacement versus time graph. Make sure that the title's labeled correctly, that you have your y-axis labeled correctly, your x-axis labeled correctly. You have a best fit line. It's linear. Your data points are generally going up. And the velocity graph should be basically a flat line for the most part. It should be labeled with a title, and your axis should be labeled. So here's what you're going to end up submitting to me at the end of this lab, basically. So this table is going to be completely filled out with all of your average total times, and interval velocities. You should have two graphs, a displacement versus time. You can also label this as S. S is the symbol for displacement versus time, T. And then a second graph, velocity versus time. The graphs should be labeled. They should both have best fit lines. They both should have error bars. I forgot to put error bars in this one. And they both should have an equation. So the ST graph, or displacement versus time graph, and a velocity versus time graph. Then, for the finale for this part, you're going to answer 6 questions. And the next part of the video is going to go through those 6 questions with you. All right, so you should have these two graphs, displacement versus time graph and a velocity versus time graph. Now the symbol for displacement in physics is S. They use S because D is already used for distance, and distance and displacement, if you remember, are different. So displacement versus time, we're going to shorten to be called S versus T, or ST graphs, and velocity versus time graphs can be called VT graphs. So it's ST graph and VT graphs. Also talk about acceleration versus time graphs, or AT graphs, in the future. But basically, this is the general shape of your graphs, ignoring the uncertainty bars, right? So what we're going to do is try to figure out the relationships between these two graphs. How can a graph show what the puck did? Can we look at the graph and be able to describe what happened to that puck? And we're going to show this relationship. There's kind of a cool relationship between displacement, velocity, and acceleration. If you have the displacement of something, and you take the slope of that graph, which is the rise over run, you find the velocity. It tells you what the velocity is. It's telling you the meters per second it's traveling. If you take the slope of the velocity graph, it tells you the acceleration, like how quickly it's changing velocity. Now you can also work backwards. Not like that, but like this. If you know the acceleration and you find the area of that graph, so if you make the graph into a shape and find the area of that shape, it tells you the velocity that that object was traveling. And if you know the velocity of the graph and you take the area of that, it tells you the total displacement. So what we're going to do is try to answer some questions about our particular data. So I just kind of sketched the graphs here. Obviously you have the real graphs with real numbers, so you're going to use those real numbers to figure it out. So the first thing we're going to do is we're going to find the slope. I'm going to erase this. What is the slope of the displacement versus time graph, an ST graph. So question 1 is find the slope. What's the slope of ST? So you're going to write down slope of ST equals blank. Now there's two different ways to find the slope. You could do rise divided by run. So let's say that this is my value. I'd go up to maybe 10 meters, and my run is maybe 8.6 seconds. So if I did the slope, I would do 10 divided by 8.6. That's the rise divided by the run. Another way to find the slope is to look at the equation that you had on your graph, and where the equation is written in terms of y equals mx plus b. Whatever is multiplied by x, that's your slope. So there should be a number here, that's your slope. We're going to use the number that Logger Pro told us, but just know how to calculate slope for future reference, all right? So I'm just going to use these numbers, 10 divided by 8.6, it's like 1.1, I don't know, I'm estimating. And then I'm going to make sure I'm actually going to show that work. 10 meters divided by 0.86 seconds equals 1.1 meters per second. The symbol is m over s. Now, what I'm going to do with my velocity graph is I'm going to look at, it should be a relative horizontal line. Now, it might not be exactly horizontal, it might be like this or like this, but I'm going to try to estimate the middle of that line. So this one you're going to use the best estimate. You're going to go to the middle of the line, go all the way to the y-axis here, and read off that number on the axis. Interesting number here. And for number 2, you're going to write down actual velocity from VT graph, and you're going to write down what that value says. And for me, I'm just going to make up a number, maybe 1.2 meters per second. Okay? Question 3 is, why are they different? They should be the same. These values should be the same, but they're not. Mine were off by 0.1. Yours would probably be pretty close, but they might be off. Why are they off, right? Describe that. Describe why they are off. There's multiple reasons, right? Question 4, we're going to look at the other relationship. Can we look at this graph and get the displacement? The answer is yes, right? So question 4 is, what is the area of the velocity graph? Area of VT graph. Now the way you find the area of that graph is you look at your best fit line, the black one for me, all right? You just have a one line across. And you take that line and you shade in everything under that line. So I draw like a vertical line at the end, and I shade in this box here. It goes from 0 up to the line. I need to find the area of that box. Well, the area of a box is base times height. Area equals base times height. The base of the box is equal to whatever that time is, all right? And the height of the box is the velocity that you recorded. So the area of the box is just going to be base times height. So the height is some sort of meters per second. I had 1.2 meters per second. I want to multiply by the base, which is some amount of time. It was 8.6 seconds. Oh look, unit analysis. Seconds cancels out with seconds. We're left with meters. It's going to give you some value in meters. So for question 4, I'm going to write down how many meters did it travel according to this graph here. 10, I don't know, whatever. Okay, question 5, I'm going to go to my displacement graph, my ST graph, and I'm going to look at it and say, well, what is the actual displacement from the ST graph? I'm going to hit equals, or say equals, and for that, all I have to do is look at my ST graph, go over to the vertical part of that graph, and read off what it says. I know it's 10, right? I know that one is 10, right? And finally, the last question is, this graph and this graph should agree. We found the answer 2 different ways, but they should agree with the same number. They might not be exactly the same number. If they are, explain why they are. If they're not, explain why they're not. So explain your answers 2, 4, and 5. Why are they different, or why are they the same? Okay? Or why could they be different? So give a brief explanation on that.